the last time you saw Sam Cushman, he was upside down in my photograph. The real thing is the right way up. He comes from the US Forest Department and is expert in landscape scale planning. Sam.
So thank you. Today I'm going to talk about connectivity and its central role in geopolitics and conservation. Connectivity is central to both all of the geopolitical changes that are going on and accelerating in the world, and also the solutions to these daunting conservation challenges that we face. So first, connectivity. The first law of geography, also is known as Tobler's law, states that all things are connected, but things that are near are more connected than things that are far. A very simple and intuitive idea. So, for example, if you go from a location, you're more likely to find things that are like that location near it, and as you get farther away, things become less related. And so in an ecosystem, if we have a location in the mountains in Idaho, where I used to work, here, we expect those conditions to degrade in similarity with distance. These concentric circles, red being more similar, yellow being less, green, blue, purple at the edge, in an isotropic pattern. That's the null expectation of Tobler's law. But in reality, things are more complicated. Different features in that landscape will affect movement or conditions differentially. And so what actually happens is, from that location, you have a pattern of connectivity which is a function of the landscape structure, where it's not a concentric set of circles, but a function of traversability, of cost, of facilitation and barriers. And understanding how structures of the environment interact to affect movement and propagation of processes is the foundation of connectivity science. So, when we have a network of points across a landscape, the connections between them are not just the distance between them, and the linkages between them are not just straight lines. Collectively, this landscape interacts, and it interacts as a function of the structure of that landscape and how it affects the processes of the ecosystem, the dispersal of populations, and you produce a network of connections that are analogous to arteries in an organism's body, the flow pattern of relationships among points. So, for example, you have about 1,000 points distributed in a perfect grid, but these red lines are the linkages, the lowest cost, the most feasible movement patterns across that landscape, in this case for black bears and their dispersal. But every process in geography or ecology is related to connectivity in analogous ways. So, to geopolitics. The British Empire in about 1880 was a huge distribution of protectorates, dominions, colonies on all continents across the world, linked by the least cost path network of shipping and transportation routes, protected by the dominant power of the Royal Navy. And that produced some very interesting patterns. Distance isn't necessarily a good proxy for connectedness or relatedness. So, for example, Dover and Calais are separated across the English Channel by about 20 miles. And Ewan told me he could swim across that gap in about 10 hours. But France and England remain worlds apart, right? Linguistically, culturally, and politically. Now, on the other hand, if you drill down under your feet 8,000 miles, you will come out in New Zealand. And because, historically, of this least cost path network of the British Empire's communication routes, there's a kinship of culture and values and perspectives and even politics between these countries that is uncanny given the distance. So, connectivity is a function of distance, but also history, also culture, and also structure of the environment. So, this is Trump's wall. And this gives us the converse picture, that things that can be very close together can be very dramatically isolated. So, for example, El Paso, Texas, and Juarez, Mexico are separated by a few meters, but they are immensely isolated politically and economically and culturally and socially by things like this wall. And so connectivity is complicated, like the human brain. For example, these are neurons in the human brain and the connections among them. Now, there are politicians on each side of the Atlantic that don't have any of these. But it is the connectivity of our neurological networks that make all human thought, emotion, and action possible. Connectivity is central to everything we are, individually and collectively, geopolitically and in conservation. So to bring this back to geography, landscapes are connected by networks of flow. For example, the hydrological network in the United States, pictured here. So when it rains in the Dakotas, it may flood hundreds or even thousands of miles downstream in Nebraska, like it is today. But conversely, if it rains in Kansas, even though only a couple dozen miles maybe from Nebraska, it won't be affected because of where it is in the network of connectivity. The connectivity network drives all of the processes, and understanding its structure, its directionality, and its scale is central. So, in the same geographical area, human economic activity is also in networks of local and regional economic zones that are centered on major commercial centers. So, in the last 50 years or so, almost all the wealth creation and all the economic growth in the United States is centered on these major commercial centers. And there has been a great sucking sound of the rural dislocation, where communities are failing, economies are faltering, and huge urban migration. And that has been a massive strain on the cultural and economic fabric of our country, leading to a rise of things like Trumpism, of this disassociation of people with their local communities and histories. And we see the same kind of pattern of urbanization leading to cultural conflicts across the world. The Yellow Vests in France, Brexit in England, law and justice in Poland, Orbán in Hungary, Putin in Russia. All of these things are associated with demographic and economic changes related to centralization of wealth and economic growth. And it's leading to a dramatic rebalancing of global geopolitics. So Europe has often been referred to as the center of the world. And you can see in this lovely projection, the prime meridian happens to go right down through near here because of the history of cultural and economic growth. And Europe is still the center of the world in terms of transportation networks. And in fact, London is the center of the world. In fact, London is the most connected airport in the world. So here's a topology of connections between the major airports across the world, first shown in geographical space, latitude and longitude, and then projected into a series of about 10 different two-dimensional spaces representing different sociological and economical factors. And so this time series of connections shows us in a visual data sense the geographical and economic and some social characteristics of the world's dominant transportation networks. So what does that mean? That gets us into information science, big data. This is the 21st century, and this is the information age. And information is the new currency of world society. So analogous to the shipping routes of the British Empire, now the submarine cable routes of the internet brings the world together and is the foundation for commerce and communication and political discussion and social interaction around the world. An unprecedented change in just a couple of decades. Changes everything that human society, how it interacts, how it expresses itself, and how it communicates. Almost exactly analogous to the power of shipping and communication across the high seas in the British Empire. And as the British Empire was ascendant because of its ability to project geopolitical power, in previous centuries, others in the rebalancing of the world today are also rising and aspiring to that kind of influence. We have all heard of China's Belt and Road Initiative. On every continent in the world, huge infrastructure projects being implemented in the goal of increasing China and projecting China's geopolitical and economic influence. Less discussed, but perhaps more important in the information age, is this China 2025 initiative, in which China is trying to obtain a leading role in the high technology foundations for economic and technological progress. In particular, building the backbone of the next generation of the internet, the 5G network. And in the world today, connectivity of information is the dominant issue for geopolitics, for political power, for economic power. Those who control information control the world. And so, in terms of connectivity and conservation, just getting back to the scientific biology side, so why do we care? We talked about connectivity in a number of geopolitical and historical factors. But in conservation of populations, we care about connectivity because population change is a function of four things, right? Things are born, individuals die. Individuals immigrate, and individuals emigrate. And all of these things are affected by connections. Connections in the landscape, proximity, ability of individuals to come into a population from elsewhere, providing demographic rescue, recolonization after local extinctions, avoidance of inbreeding depression through loss of genetic diversity. So in a population context for, let's say, wildlife, we're interested in connectivity because it is a foundation of population dynamics, and solutions to conservation problems are often optimized by considering how connectivity affects the births, the deaths, the immigration and emigration of that population. So connectivity between locations. How do we understand it? It's not just distance, it's not just a straight line. So connection from that location to that location on a landscape depicted here as costs of movement might be reflected as a least cost path. And you might develop a conservation strategy to protect the important corridor between those points. We can represent that more holistically as not just a single path, but as a corridor or a network of paths that all have a relatively low cost, which gives us a better representation of the connections, not just a single path, which goes through here somewhere, but a number of ways between them. And often, we're more interested in the synoptic connectivity across a full network rather than between just one pair of points. So we can generalize this least cost path into this network, this vascular system of connectivity, as I showed you earlier here. So instead of one least cost path between 2 points, there's hundreds of thousands of least cost paths, all integrated together, showing the dominant routes of movement across this whole system. And that allows us to predict rates, patterns of movement processes, propagation of disturbances, input of invasive species, are all a function of connectivity. And understanding the network of connectivity is key to predicting and mitigating ecological challenges. And analogous to this, a corridor between 2 points in a synoptic way could be represented as an incidence function of movement. Not going to get into technical details, but you can use local dispersal kernels, cost weighted, add them up, and you get in the color ramp from red to blue areas that go from very, very high rates of movement of individuals through each location to areas where there's very low rates of movement, predicted to be barriers. And so these two things together give us a composite view of the key processes of connectivity, rates of movement in every location, and linkages across the full network. And so, to bring that back to the global geopolitical scale and how we have been trying to implement and use these ideas, let's consider how the world is changing. In 1980, wealth was concentrated in Europe and North America, very highly. But in the last 20 years, and accelerating into the future, economic growth is not in those places. Economic growth is in Asia, and increasingly in Africa. So this rebalancing, where the views, the norms, the values, the policies of Europe and largely the United States have been dominant in the world, is not going to be the future. The future is a world that's more balanced in terms of wealth, but we have to also find a way to solve the collective action problem, to understand each other's cultures, and develop a shared sense of values and perspectives. And, perhaps equally or more important, climate change. And the impacts of climate change globally are not equally distributed. The negative impacts of climate change on GDP, for example, are projected to be concentrated in Africa, Latin America, and Southeast Asia. And that, coupled with, as we discussed, the projected changes in human population, lead to potentially massive dislocations of human populations if greatly expanding populations in places like Africa, coupled with climate change impacting agriculture in those areas, lead to conflicts which promote mass migrations, and that complicates conservation efforts. So, in the world, there are a number of biodiversity hotspots, areas with very high species richness and endemism that are also under threat. And given what we just saw with patterns of economic growth, patterns of population growth, where climate change impacts will be most severe, we can identify Africa and Southeast Asia as areas that are going to be particularly challenging for conservation. So, in the example of Africa, WildCRU has been working on lions in Africa for many decades now, and we were fortunate to be able to work together to implement a study of lion movement in a transboundary area in southern Africa, spanning parts of 5 nations. And looking at the movement patterns of individual lions, we could develop a model of this landscape resistance, which is the cost of movement. So it's not an isotropic process. Different features affect movement in different ways. And from that, we can model the connectivity in the current landscape and project different scenarios of future connectivity and optimize conservation plans. So for example, we can put down the distribution and density expected in the current population on this map of cost of movement developed from telemetry data, And we can then predict this incidence function, the rate of movement across the landscape, where red areas are core areas with high rates of movement of dispersing lions. And then we can identify which of those core areas are outside of protected areas and which ones are most important to maintain regional connectivity among that lion population, and prioritize them for conservation based on that importance. Then we can use this network of least cost path idea to identify the most important linkages among those core areas. So the main corridors, this one, and this one, and that one, that are the strongest and most essential linkages between the main populations of lions across southern Africa. And use that information to not just say lions need habitat and they need connectivity, but we need to know detailed and specific which areas are most important and why. And then be able to communicate that simply and easily in a form that decision makers can understand, and then work with them in a co-creation, shared stewardship model to implement conservation actions that will be efficient and effective. So in Asia, been a tremendous rate of development and loss of habitat. WildCRU has been working, as David mentioned earlier, on clouded leopards, in probably the largest camera trapping study ever conducted across the species range. And from that, we were able to model, and Jeanette tomorrow will tell us more about, core areas and corridors across a large multinational extent. And so, what have we learned from this? We've learned some very simple things. First, we have to prevent a population from being killed through direct mortality. As Alex was talking about, wildlife conflict is a huge challenge. We first must keep the animals alive. And then second, protect the large core habitat and population areas. Third, corridors linking them. And fourth, multiple use buffers surrounding them. So those are easy guidelines. But with tools like I showed you, we can do more than just say guidelines. We can say which areas are highest importance and under which scenarios of future change can we promote the best trade-off between development and conservation. But in the context of geopolitics, the rebalancing of power and wealth and influence in the world, it's becoming very, very difficult to cooperate. Working together, it's feasible to solve big problems. But with individuals pursuing their own agendas, it's very hard to solve big collective action problems. That's the biggest challenge in geopolitics and conservation today. So to wrap up, the world is in our hands, and we need to focus on connectivity. Connectivity not just of ecosystems, but of cultures and politics and decision making, because cooperation at a global scale is the solution, and tools like connectivity science are only tools, and we must work in a collaborative way to implement across boundaries and address the challenges we face collectively. Thanks.
Wonderful. We have a moment for a quick question for Sam, and then coffee away. Yes.
How do you balance out the need to make trade-offs with connectivity, thinking in particular of CASA and the recent Botswana ministerial report that suggested fencing off or closing down some of migration routes? Where do you balance between the need to keep migration routes and corridors open, but also the need to respond to local people and their grievances so that connectivity doesn't become an even greater grievance?
That's a very good question. The science of connectivity or population biology is not a solution. It is a source of information. And the decisions are made by people balancing a number of objectives: economic development, human welfare, as well as conservation. And so what we hope to do is to be able to provide quantitative evaluation of alternative scenarios. If you do this, that's the impact. If you do that, that's the impact. And we can import economic and social value and then do a trade-off analysis. So we would never be so naive as to say Connectivity is important, therefore protect it all, because that's not likely to happen. But by prioritizing and then doing an integration with economic and social value and trade-off analysis, we can provide decision makers with information about the relative advantage and optimize the decision-making space.
Thank you. My question would actually even be addressed to all the previous speakers, and including you, and maybe I don't know if it will be you will be answering or Don, but maybe one of you will try to address it. I think as we're addressing, I'm Edmund Mukala from UNESCO, Chief of Africa Unit for World Heritage Convention. I'm listening, and we are talking about geopolitics and conservation. And I think, maybe because I've missed the session of yesterday probably, one of the things that is really ringing back into my mind is the issue of how are we addressing or looking into that very geopolitics. Coming from Africa, I will say that in many of the cases that we see in all the countries, problems, the roots of the problems doesn't really start with the populations or the governments that are right there, but we are actually looking that the root goes beyond. We're talking about, with geopolitics, we talk about superpowers. And we know how superpowers operates in various ways, including also the multinational companies and the great tourist industry that's been working. And just taking even a very tiny example, I think it was a presentation that was really looking into the culture sensitiveness and the communities or in years where we were really seeing the part of the local communities or the local populations and also all the threats on some of these species. Let's look at just one poor local community African man in the village of Botswana. He will not go and do the hunting unless there is a big tourist financing system behind to come and bring the money. So when you try to really look at the root of all the problems, it brings us back to the origin, to the countries, where the one that we call the big superpower. And that's even why the reason I think it was important for me to come here, because it's one of the superpowers. And then my question is then how, through discovering, which is a very important one, are we also, through scientific documentation and information, we're trying now to raise awareness of the decision makers in this part of the world to see how from this area we started really addressing the problems where we're only seeing the consequences and trying really to buckle our heads in trying to find out the local solution. But I will say one of the biggest solutions to start from the superpowers. I know they are superpowers, so they're not really easy to be addressed to, but I think we can, with the data and with the statistics and the research that has been done, there could be ways in which we can address them, sensitize, call them into attention, because the rule of law is really applicable in this part of the world compared to the one that we are addressing to. So how do we do that? I'm still thirsty. I'm really looking into how we can really address it, because if we start addressing at that higher level, I'm pretty much sure that we will already try to cover 50% of some of the challenges that we are talking on the countries, in particular the case of Africa that we have seen. I don't know if I've tried to address my thoughts, but it is a question, it's a remark, but also it is a call in hearing more how at the geopolitics, at that level, these things are being addressed. Thank you.
So, if I may really quickly, it's a very complicated question, and there are no simple answers to it. But in the context of my talk of connectivity, it's communication and integration and understanding, where people in the superpowers, as you call them, need to understand more the lives of the people in the developing nations and the factors that drive their decisions and their values. And trying to share that understanding will help cooperation to improve the lives of these people, but also optimize the trade-off with conservation and development. Really, it goes to respect and understanding, humility, and taking an interest in each other's lives and the factors that affect them and what matters to us. I think that's the fundamental thing.
Thank you, and thank you for your comments. If I would just add two quick thoughts as well, because I think the questions you posed to Sam and to the meeting are actually very much the ones that have brought us here together, and I hope more answers will emerge in the coming days. But two quick points. One is scale. I think scale is very important, because many of us here have spent our careers working, I think rightly, at a very small scale, dealing with exactly the people and their needs that you mentioned, the poor farmer who has his cow that might be lost to the lion, and looking for solutions. A big question is how, having got solutions, they can be scaled up to a regional, national, continental level. A second point is the interface between conservation and development. And a couple of years ago we had a meeting here and you sent us a wonderful message actually to launch that, where we talked about these two things, conservation and development, and came up with a phrase that I've been beating the drum of ever since, which is conservation-led development. So I think one of the things we could seek to understand better here is how conservation can become, conservation I mean biodiversity, the wider environment, nature as a whole, can take a role that leads as well as follows development for a better future for the environment and its working parts and people as well. So I think that's very much part of what we're doing here. Let's applaud Sam again.